Hello, everyone. Welcome back to another P-stat example. Today, we're going to talk about some sampling distributions. So sampling distributions is where you take a sample from a population, and then you're going to summarize that sample in various ways. For P-stat 109, we're going to look at 3 sampling distributions. So today, in this video here, you're going to see 2 of the 3 sampling distributions. So first up, we've got a normal population here. The mean and variance is given. And we have a sample of size 20. So what I like to do is I like to just identify all my pieces here. So we have n equals 20. And the question is asking, okay, well, what's the chance that the average of those 20 random variables will be under 48? And so the highlight here is it's talking about sample mean. So that tells me it's a probability question. The sample mean is denoted capital X bar under 48. And so I know now my random variable of interest is X bar. And if you recall, one of the properties we have is as follows. If your X's are normal, with mean mu, variance sigma squared, then X bar, which again is the average of a bunch of X's, will also be normal with the exact same mu, but now the variance is sigma squared over n. Right, so that's a property of normal distributions, and that's the property we're using here because we know that our X's are normal. So in order to finish this with all normal distributions, we will need to convert X to, or in this case, X bar to a z-score. Right, so if you recall here, our equation for converting z is we take the random variable, we subtract its mean, and then we divide by its standard deviation. And what we have to notice for this particular problem is we're not converting x, but instead we're converting x bar. So that means we want the mean of x bar and also the standard deviation of x bar. So it's the same principle, but we are applying a different random variable to it. And I can convert to a z-score because, as the property right above in yellow says, x bar is also normally distributed. So in my next steps to take this to a z-score, I'm going to follow the equation in red on the right. So I'm going to subtract the mean of x bar, which we know is the same as the mean of x, and that's given to us as 50. And then divide by the standard deviation of x bar, which will be my standard deviation, which is 5, since the variance is 25, divided by square root of n, which is 20. And so just off to the side here, this symbol, sigma squared over n, is the variance of x bar. And what I need to do is take the square root of it to get the standard deviation of x bar. And so that's where all these numbers come from. And now when I simplify by plugging this arithmetic into my calculator, I get a z-score of negative 1.79. And then now that's the same as looking up the z table of negative 1.79. This is already the error to the left. And so now using my table, I can see this probability is 0.367. So that's the probability example working with our x bar.